Hi and welcome to another video tutorial. In this video tutorial I'm going to be going through the basics of IPv4 addressing. So what does an IPv4 address look like? Well, an IPv4 address is made up of 32 bits which are split into a network part and a host part. And because an IPv4 address uses 32 bits, the address space, or the total number of possible addresses, is limited to 2 to the power of 32 addresses, or just over 4 billion. And this number here, which is well over 4 billion addresses, seems to us to be quite a big number of addresses, but in actual fact, if you consider that nowadays we've got all of the Internet of Things devices, cars need to be able to access the internet and have IP addresses nowadays and things like that. There's so many more devices on the internet now than when IPv4 was devised. Come up to some problems with this only having this number of addresses in the very near future, which is why there have been various techniques devised to extend the life of IPv4, and also now IPv6, which is the new version of the new addressing scheme, is coming into use across the world. But it's going to take a long time for IPv6 to come into common use, because there are so many legacy devices that only support IPv4, so that coexistence of IPv4 and IPv6 is going to have to continue for a very long time. Okay, so how do we write down an IPv4 address then? So what does it actually look like? Well, we can write an IPv4 address in binary, so here's an example. But that's quite a long thing to have to write down, and it's not immediately clear what the address is, so we often write it in dotted decimal notation, and we do this by converting each of these bytes, which makes up the address, so there's 4 bytes in an IPv4 address, convert that to decimal. So this in decimal is 192, this is 168, this is 10, and this is 2. And then we get our dotted decimal notation form of the IPv4 address, and that's much easier to read. And this particular address I can immediately see is a Class C address. I'll come on to why I can tell there's a Class C address in a minute. And what that means is that these 3 bytes here are used to denote the network part of the address, and this byte here is used to denote the host part of the address. So IPv4 addresses are split into various classes, and one of the reasons for doing this is so that we can we don't just have to have one number of one number of bits in the address to signify the network part, and one number of bits in the address to signify the host part. We can have different numbers depending on what class a address is in, and it turns out that the address classes don't actually give us that much flexibility in determining the number of bits that are used for the network part and the number of bits that are used for the host part. So we have things like subnetting, which are used to give us more flexibility with that, but subnetting is beyond the scope of this video. Today, in this video, I'm just going to talk about the different classes of IPv4 address. Okay, so with Class A addresses, 0 is always the leading bit. 7 bits are used for the network part of the address, and 24 bits are used for the host part of the address. And what that means is that because 7 bits are used for the network part of the address, I can have 2 to the 7 networks, which is 128 networks using Class A addresses. And on each of those networks, I can have 2 to the 24 hosts, and that translates. That is 16,777,216 hosts. Okay, so that's Class A addresses. So that's how many networks we can have with Class A addresses, and that's how many hosts we can have on each network. Let's take a look at Class B. Okay, so with Class B addresses, 1, 0 are the leading bits. We've got 16 bits are used for the network part of the address, so that's the next 16 bits after the first 2 bits are used for the network part of the address, and the remaining 16 bits are used for the host part of the address. And what that gives us is 2 to the 14 networks, and that works out to be 16,384 networks, and that gives us also 2 to the 16 hosts, which works out to be 65,536. And I've just noticed a mistake here. That should be 8 bits, and that's correct. And the 8 bits include this leading bit here, and similarly here, the 16 bits in the network part include these 2 leading bits here, which is why we've only got 2 to the 14 network, 2 to 14 networks with Class B addresses. So finally, then let's look at Class C. So with Class C, we've got 1, 1, 0 as the leading bits, and then we've got 24 network bits, and we've got 8 host bits. And what that gives us is 2 to the 21 networks, and that's because we've got these 3 leading bits here, so we have to do 24 minus 3 to get 2 to the 21 there, and that gives us 2,097,152 networks, and with 8 host bits we can have 256 hosts on each network. Okay, so those are the different classes of IPv4 addresses that you're likely to come across. There is such a thing as a Class D address, but that's not for unicast communication. It's not for unicast traffic, and all that means is unicast is sending a packet to a single PC. And Class E, there is such a thing as a Class E address as well, but those addresses are reserved and they're not used on the public internet. So you're likely to just come across Class A to C pretty much. But do feel free to look at Class D and E, what they are as well. So going back to the previous example then that I had of an IPv4 address here, the reason I knew it was a Class C address is because of this first byte here. Because the leading bits were 2 1s and a 0, just there, 2 1s and a 0. I knew that that must be a Class C address, and also I can work that out if I only have the dotted decimal as well, because 2 1s and a 0, if all of the rest of the bits in that byte are 0, then 128 plus 64 gives me 192. So if it's if the first number here before the dot is 192 or more, then it's going to be a Class C address. That is, of course, assuming that we're only using we're only looking at Class A to C addresses. Okay, so that's the basics of IPv4 addressing. Obviously, we're going to run into issues here with the with the address space, and there's some ways that have been used come up with to solve that problem, extend the life of IPv4, and then obviously we've got IPv6, which I'll look at in another video. And also this class system here doesn't give us too much flexibility in terms of how many bits we can use for the network part of the address and how many bits we can use for the host part of an address. And there's ways of giving us more flexibility there as well. So those are topics that I'll cover in other videos. But the main thing to get out of this video is the structure of an IPv4 address, which is 32 bits are used for the address, split into 4 bytes, and the 32 bits are divided into a network part and a host part. Okay, so that brings us to the end of this tutorial video. I hope you found this tutorial useful, and thanks for watching.